This video is to cover a couple of concepts like involving completing the square. So I want you to get a piece of paper and title this page Complete the Square. And we have talked about several methods to solve quadratic equations. To solve, remember, is to find the solutions or to find the zeros. So far we have covered factoring, right? Also by looking at the graph and using the x-intercepts, and we also cover by looking at the table. Now, completing the square is another one of those methods, and you will see it on a couple of problems from the homework, online homework 6. So that is why I want to do this with you guys right now. So whenever we complete the square, what we're trying to do is we're trying to come up with a number that will go here that will make this trinomial turn into a perfect trinomial square. So we're going to force the expression to be a perfect trinomial square. And why do we want to do that? Because we want to be able to factor it as a binomial square so that we can solve a quadratic equation. There are other reasons why we use complete the square, but that's one of them. So if you guys recall, binomials of this form, when you expand them, they look like this: a squared plus 2 times the product of a times b. So we double that product, and then we have b squared. So the key is here in that doubling part. So when we complete the square, what we have to think of is that, oh, and I'm missing an x here. So it should be x squared minus 12x plus, and then blank. So what we need to think of is that this number here, it is representing 2 times the product of 2 other numbers. This negative 12. And of course, one of those will be x, but we have to find the other number. So that number right there is going to come from taking half of 12. So what is half of 12? 6, right? But if I ask you what is half of negative 12? So that would be negative 6. That's right. Now, we are going to complete the square. So that means that this number will go here, negative 6. If you think about it, if you double the product of negative 6 times x, you will get negative 12x, which is this term in the middle. So the shortcut is just for you to look at this number, negative 12, and think about what is half of negative 12. The answer is negative 6. So now what you do is you square it, like that. Now, whenever you are working with an equation, whatever you do to one side, you need to do it to the other. So I'm also going to add that quantity here, negative 6 squared. All right? And so what we do now is we simplify. So we have x squared minus 12x. Now, what is negative 6 squared? Negative 36. Positive, because negative times negative is positive. So positive 36. And here again we have positive 36. All right. Now that we have done that, we could factor this one into a binomial square. And the factoring is pretty simple. It will be x. And you could look at the number that we used here, which is negative 6. And so that same number is the one that goes here, minus 6 squared. And that equals to 36. Now, if we were trying to solve for this equation, my next step will be to get rid of the square. How can I get rid of a square?
By putting x minus 6 and x minus 6.
No.
No.
What is the inverse operation of squaring something?
Square root.
Square root. So we square root on both sides. That square root cancels with the square, so we get x minus 6. And the square root of 36 is positive 6, but also negative 6. So remember, from here we get two equations. X minus 6 is equal to positive 6, and x minus 6 is equal to negative 6. So we solve for x. X is equal to 6 plus 6, which is 12. And the other one will be x is equal to negative 6 plus 6, which is equal to 0. And so this 2 right here will be the solutions for the equation. Okay, I'm going to cover one more problem. So this is completing the square. Remember, we look at this number and we take half of that number, which was negative 6, and then we square it. And we have to do it to both sides of the equation. After you do that, you factor like a binomial square, and then you could take the square root on both sides. Now, the next thing I want to cover is how to go from the general form of a quadratic equation to the standard form, which is the vertex form. To refresh your mind a little bit, general form is the one that looks like this. The one where is the easiest thing is to get the y-intercept by looking at the constant, and the standard form is the one that looks like this. All right, so there's a question on your homework where they ask you to do something like that. And so one of the equations, it looks like this. It has 3x squared minus 18x plus 31. So what we're going to do is this is another use of completing the square. So before you can complete the square, you have to make sure that the coefficient of the x squared, the leading coefficient, is only equal to 1. And if you notice, here we don't have that happening. So we're going to have to do the following thing. I'm going to group the first two terms. And then I'm going to factor a GCF. So what will be the GCF here? Kevin? Okay. 3. Yes, just the 3. So we factor out a 3. And then we will get x squared minus 6. We still have a plus 31 here. After we factor out the GCF, now we can go ahead and complete the square with the expression that is inside the parentheses. So in this case, will be x squared minus 6. Oh, I'm sorry, I forgot. There's an x there. Minus 6x. And now remember, what we need to do is, and let's not forget there's a plus 31 here. What we need to do is take half of negative 6. What is half of negative 6?
Negative 3.
Negative 3. And then we are going to square it. Now, in this case, we're working on the same side of the equal sign. So for us to not change the function, what we need to do is, if we are adding negative 3 squared, we have to also subtract it. So we add and we subtract. The difference with the previous problem was that we were working on both sides of the equation, so we added negative 6 squared to both sides to keep them balanced, okay, to keep the equation still equal. The problem that I have on the next slide, this one, we are working on the same side of the equal sign. So no, we don't need to add it to both sides. We simply need to add it and subtract it. Because if we add 9 and we subtract 9, how much are we adding in total? What? What is 9 plus 9 minus 9? 0. So we're adding 0. So we're not really changing the equation or the function. We're just changing the writing a little bit. So going back here, let me simplify it. So negative 3 squared is positive 9. here I have plus 31 and then minus 9. That's what I was talking about. Adding 9, subtracting 9. Oh, actually, I made a little mistake. If we consider that 3 times 9, what is 3 times 9? 27. So then what I should be subtracting here is not just 9. It should be 27. Because that is the product of 3 times 9. All right, going back here, I'm going to factor the trinomial square into a binomial square. And so that will be x, and what will be the next number that we need for our binomial? And that number, you can look at this one here. What is that?
-3.
So -3. And what we do here is we combine like terms, so 31 minus 27, that should be positive 4. So now from here, we have gone from the general form to the standard form of the quadratic equation. If we look at this one, it's very easy to figure out what the vertex is, right? The vertex, we take the opposite of this number, that's positive 3, and the same number as this one. We were talking about transformations, which you will have a couple of those questions on your test. The -3 is a horizontal shifting, right? 3 units to the right. The positive 4 is a vertical shift to 4 units up. What about this 3? What is this 3 doing? It is outside, so is it going to be vertical stretch or horizontal stretch? Vertical stretch. So since it multiplies all the y values by 3, it's going to make them larger. All right, so this is the end of this video for completing the square. I hope it helps with your homework.